I'm Michele. I'm a PhD candidate at King's College London, where I study geospatial technologies in the context of smart cities, which is the fancy academic description to say that I work a lot with data and maps, mostly in sometimes in JavaScript, but I don't really want to go in that direction. So tonight I'm going to talk about Invisible Cities, which is a project I participated in a few months ago during a machine learning for artists workshop in a Fab Lab makerspace in Milan with the amazing artist and programmer Jim Kogan, who, by the way, was at PyData a month ago, so probably some of you have seen him. And so 1 week before this workshop, a paper came out, image-to-image translation using convolutional adversarial networks by Isola et al. And from that paper, a technique called pix-to-pix. I'm pretty sure most of you have seen this picture. It's an online demo, and also the slides are online, so you can click on the demo and test it. Basically, you can draw a cat, and the demo gives you back an image of a cat. Because this pix-to-pix technique, it's an image-to-image translation process in which you can map an input image to an output one based on some corresponding features. So without going into much detail, this is a data set of building facades. So you feed the network to training data sets of imagery. In this case, one is basically pictures of buildings, and another one of color-coded polygons. And the network learned the correspondences. So a red polygon becomes a door, this green one becomes the balcony, and so on and so forth. So the next time you feed the network an image like this, a new one that the network has never seen, it's able to reconstruct what effectively looks like a photographic image, but is completely made up, which is kind of mind-blowing. And so this is an online tool. And of course, with most offline tool, like, things start quite innocent, and then they eventually progress to a really uncanny valley. So you can use this mind-blowing technique for this kind of stuff, or that's what we did. We applied it to geographic data. So we downloaded a data set of map tiles from OpenStreetMap. And for those of you who don't know it, it's basically the Wikipedia of maps. We color-coded the land use, so all the buildings are colored in red, the water is blue, and so on and so forth. And then we downloaded also a corresponding data set of satellite imagery from the same location. And so this is Venice. And when you present to the network a new image that the network has never seen, like in this case, this is central Venice, you can see the S shape of the Canal Grande, the network is able to reconstruct what it looks like an image taken from space, but this is completely fake. This is the real one. But I mean, it's pretty darn close. And then, of course, you're not stuck to using, to train the network on just one city, to use just one city style. You can use different cities. So we thought, well, what is a most contrasting city compared to Venice? In Venice, there are no cars. So why not use Los Angeles, which basically is sprawled in the suburbia thanks to cars? And what you can do then is to train the network on the data set from Los Angeles, for instance, but then present an image from Venice. And that image gets translated in the style of Los Angeles, or vice versa. So you present the style of Venice, and you have it given back in output as Los Angeles. And oops, I'm going to zoom in so it's clearer. So in this case, this is a map tile from Los Angeles. This is the actual map tile. So there's just a river somewhere with a river with a concrete embankment that gets translated in the Venetian style in a beautiful Venetian canal with actual gondolas in it. And then, of course, you don't need to use real cities. You can make your own one. So we kind of redrew the logo of the makerspace, same as an island, and we started with the Los Angeles style, and then with the Venice one. And I mean, Venice looks much better simply because there are more water tiles in the training set for Venice. OK, I'm just going to wrap it up with a quote from a famous Italian writer, Italo Calvino, that wrote the Invisible Cities book that inspired this project. And this quote can be roughly translated as, invisible cities are like dreams or dreamlikes that are born from the unbearability, for the unbearableness of today's urban living. And as a researcher that tries to integrate technology into cities, I think these kind of techniques, this kind of technology can really help like architects and planners into quickly prototype, quickly design their ideas, and having them come alive, and hopefully help us designing the cities of tomorrow. Thank you.
Any quick question? Not a monologue.
Have you tried other models of cities, or just 2 models?
No, we tried a few ones. We started with Venice because it's quite unique. It's quite homogeneous. There are basically all the buildings look the same. There are not many roads. We tried with Milan because the workshop was in Milan, so we wanted to see it. We also had the idea to test it like, let's say in third world countries, to compare it with like richer countries as a way to swap the style and kind of raise some like social issues or style. I don't know, Lagos in Nigeria with New York or somewhere, or vice versa. The problem is you need quite a consistent data set to get good results. That's why the Los Angeles bit applied to Venice kind of look wobbly, because there's too much variability in the landscape of Los Angeles as opposed to Venice.
Any other question out there?
Hi, so regarding the image with the reconstruction of the building,
yeah.
I was wondering, so you specified all the objects in the image, but how did it capture the color of the building?
So you color code the image before? Is that your question?
Yeah, how the reconstructed image has, all the buildings have the same color, the same brown color, and how different colors from the training set.
Because it's not just based on colors. There are multiple features that the network extracts, like the geometry, the position within the picture. The color coding is just a way to label. I know that this particular area of the picture is going to be a window or a door. Hope that makes sense.
Last question. Anyone? Perfect. Oh.
What's your favorite module to create maps in Python?
What a DataBeers question.
Yeah. I work with web maps, so I like the binding to leaflets or volume. It's quite nice, although it's quite basic, but it's quite effective. So I'll go for volume.
There is a very strong developer of volume here in the room.
Oh yeah?
Come on, Antonio.
All right. That guy. All right.
Cool. Thank you, Michele.
Thank you.
Thank you all.